Hello, good evening. Welcome to this unique live technical discussion series. And today we are going to talk about stiffness modifiers as per IS code. Okay. Uh, so we have received many interesting questions through registration form. So based on that, I have created small PPT around 8 to 9 slides that will be looking very quickly. And thereafter, I will be taking up questions through which are coming through the live chat. Okay. Yeah. So welcome Raghuram, welcome Abhijit, welcome Krishna Sahakari, welcome Ravichandra. Okay, welcome Olao, welcome Samir Bendre. So whenever we talk about stiffness modifier, it is a relatively new concept, I would say, for Indian standards. And that's why probably there are certain practical difficulties when we are performing analysis using stiffness modifiers. Right? So in fact, we conducted exactly before 1 year couple of live streams for stiffness modifiers. But till today we are receiving a few queries from the engineer, and also there were a few requests that why don't we arrange again similar kind of a live technical discussion series for the stiffness modifiers, right? uh, so once again, very good evening to all, and welcome to this unique live technical discussion series. So today we are going to focus on stiffness modifiers as per Indian standard codes. Yes, Ravi Chandra has already started putting certain points. So, on which code today you are discussing, sir? It is 1893 or 16700? See, today we will be talking about all the codes 1893, 16700, as well as we'll be also talking about application of the stiffness modifiers in different software. So, I have prepared a small PPT which I'll be just sharing after a few minutes. Okay, welcome. Naveen, welcome Suhas Bhai, welcome Dwarika. Okay, welcome Vijay Kumar. Yes, welcome Naresh. So we have received many interesting questions, while going through the registration form. Yeah, and from those questions, after compiling those questions, I have put up around 8 to 9 slides that will be looking at it. But again, I have attempted only a few of the questions. There are many interesting questions which are remaining, which will be keeping taking up as and when we receive the many important points from you through the live chat. Okay. Okay, so once again, a very good evening to all, and welcome to this unique live technical discussion series. And before we start, let me tell you that we are having a quite aggressive plan for conducting this kind of live technical discussion on very important topics wherever we are facing practical difficulties in our routine analysis or say design. So if you have not yet subscribed to our YouTube channel, please subscribe so that you will get the notification whenever we go live. Okay. Uh, See, today our focus on India stiffness modifiers on specifically on Indian standard codes. So first of all, let us discuss only one code instead of mixing different codes. Otherwise, we'll get confused. So today our today's focus is on stiffness modifiers as per Indian standard codes. Okay. Yes, welcome Mohan. Can we do a small comparison with international codes on stiffness modifiers? Yes, certainly we can do it. We can have separate session for that. But today, let's talk specifically about stiffness modifiers as per Indian Standard Code. Yes, welcome Ashish. Okay, so let me share the small presentation. which I have compiled based on the queries, general queries which we have received through the registration form. Okay. And meanwhile, you can start putting your questions, your doubts in the chat box. Okay. Yes. Good evening. Is from Riyadh. Most welcome. Okay. So let us share the presentation now. Okay. The first basic question which we got in the registration form is why stiffness modifiers are introduced. So let's say before introduction of the stiffness modifiers in our analysis, we were using 100% moment of inertia, right, for the different elements. And after introduction of the stiffness modifier, we are actually reducing the stiffness of different elements. Now, why stiffness modifiers have been introduced? Because as we all know that whenever we are talking about reinforced concrete structures, then always there is a possibility of cracks in different elements. Now, the extent of cracking will vary from member to member, and there are a number of factors on which this cracking is dependent upon, right? So in the earlier analysis where the stiffness modifiers were not in the picture, we were considering 100% gross moment of inertia for the cross sections for different elements, right? Now, these stiffness modifiers are introduced because in reality, there will be certain cracks in the tension zone in different reinforced concrete structure elements. And just to take care of those cracks, these stiffness modifiers are introduced. So we may say that it's a kind of a more realistic analysis we are performing whenever we are introducing stiffness modifiers in our analytical model. Okay. Now, this is interesting slide. Like, see, firstly, whenever we talk about Indian standard, then stiffness modifiers were firstly introduced in 2013 in the code IS 15988 2013. Now, this 15988 is for the seismic evaluation for, let's say, for the retrofitting of the existing RCC structures. So probably this, this stiffness modifier introduction didn't get this kind of a limelight, like the stiffness modifiers, which got in 1893 and 16700. But here I would say that this was the most exhaustive table whenever we talk about stiffness modifier. See, in the first column, we can see this is for beam, which is non-pre-stressed, then beam pre-stressed, then column in compression. Now, depending upon the extent of compressive force, there are different values, 0.7 and 0.5. Now, I think there may be some typographical error, in my opinion, maybe in this line, probably. Again, the stiffness modifiers are defined for the walls which are uncracked and cracked. And for flat slab, it was said that to be determined based on the rational procedure. So this is the flexural rigidity, which is the column number 3. Okay. And column number 4 is talking about shear rigidity. So we received very interesting question from one of the engineer from Nepal. I'm not sure whether she is online or not, but there was a question like whether Indian standard codes are focusing on the reduction of the shear rigidity also while talking about stiffness modifiers. So when we'll go to 1893 and 16700 after this slide, but in this 15988 2013, this was introduced. Shear rigidity reduction was introduced for the column. For raised element, it is said that reduction is not required. And the last column is for the axial rigidity. Okay, and we can see for majority of the cases it is the 100% area which we can utilize. So this was the table introduced in 2013. So this is one of the reference which we can utilize if you want to get more understanding about stiffness modifiers. Now let's come to this most important part. So in IS 1893 2016 part 1, this stiffness modifiers were introduced, which is para number 6.4.3.1, as we all know. And for the column, the stiffness modifier is zero point 0.7, and for the beam it is 0.35. And again, here we are talking only about reduction in the flexural rigidity, or say reduction in the moment of inertia, right? And for the column, the stiffness modifier value is higher than the beam, because the column is naturally going to have a higher amount of axial compressive force as compared to the beam. That's why the this figure is higher for the columns as compared to the beam. Uh, and now, what does it mean that for all the beams in the structure, we will have to apply 0.35 for all the beams, and for all the columns, we will have to apply this factor 0.7. Now these factors actually vary. See, if we do exact crack analysis, or if we start measuring actual cracks in different elements, then definitely the extent of cracking will be different than this identified unique value. But just to make our life easier, the unique value is identified, which we can apply in the entire structure. Now whatever I'm sharing right now, it's based on my experience, my understanding. So always I'd like to see your opinion, your understanding, your experience. And if there is a difference of opinion, I'd be glad to receive the details through the live chat, and then we will discuss it further, maybe in this session or in the next session. So now what I understand from this clause here, that these stiffness modifiers are specified only for the seismic load, which is the ultimate load case in IS 1893 part 1 2016. Okay, now let's go to IS 16700 2017. So thereafter, stiffness modifiers were introduced in 16700. And here we can see that there are two conditions. One is the unfactored loads, and another is the factor loads. Now this has been debated several times. So these unfactored loads is for the serviceability condition, or let's say for the dead load, live load, or for the wind load condition. And this factored loads is for the earthquake load condition, right? So in the first column we can see the slab, beam, wall, and columns are the different elements. And if we have to compare firstly these stiffness modifiers with the stiffness modifiers which are defined in 1893 part 1 2016, then here we can compare it. Like for beam it is 0.35, and for columns it is 0.7. So these stiffness modifier are exactly matching for the earthquake load case, which is, let us say, ultimate load case, right? And here we can see that for similar beam and columns, the stiffness modifier values are higher as compared to the ultimate load case, or let's say for the earthquake load case, as compared to the modifier for the, let's say, for the dead load, live load, and the wind load case. So here this factor is zero point 0.7 as against 0.35 for the beams, and for the columns it is 0.9 as against 0.7. So why these factors are higher? Because in the say serviceability condition, the extent of cracking would be lesser as compared to the ultimate condition, and that's why these factors are higher, right? Which is 0.7, 0.9. Now, in addition to beams and columns, also stiffness modifiers are suggested for the slabs as well as for the walls. So for the slabs, it is 0.35 for the serviceability condition, 0.35 IG, and it's 0.25 IG for the ultimate condition, right? And for the walls, this value is zero point 0.9 and zero point 0.7. Okay. Now there is one more clause in 16700 2017, which is sensitivity analysis, and there were few queries which we received on this part. So what it says that as a part of the collapse prevention evaluation, two sets of backstay sensitivity analysis shall be carried out using upper bound and lower bound cracked section properties of floor diaphragms and the stiffness parameters for those diaphragms and perimeter walls of podium and below the level of the backstay. So these are the upper bound and the lower bound values. And here we can see the upper bound value is zero point 0.5 in terms of moment of inertia, uh, as well as the in terms of the area, and the lower bound value is only 0.15. So these two kind of analysis are required because we are not exactly certain, or we are not pretty certain that how much effect backstay will be providing. Of course, that's a separate topic we can discuss and debate separately, but for with these we will have to carry one more analysis using these modifiers in addition to the modifiers which we have just seen as per the table number 6. Okay. Okay, now let's come to a very interesting part. So I have tried to prepare a few slides as per my understanding. Now, when we talk about stiffness modifier for the columns, now, firstly, I have taken staad.pro for the discussion. And right now, we are talking about the stiffness modifier as per ISO 1893 Part 1 2016. So as we remember that for the column, this factor is zero point 0.7. Okay. So whenever we are entering these stiffness modifier for the column, we have to go get into this command, which is property reduction factors. We need to pick up this code 1893 2016, and then we have to add 0.7, which is for the major and the minor direction of the column. Now, the most important part here is that these stiffness modifiers are affecting moment of inertia only for the seismic load case. Now, this is what I have gathered based on my sample or study models. And what I could get that whenever we apply this stiffness modifier in the staad.pro, then this stiffness modifier is only affecting the analysis, or say only results of the seismic load case. So meaning, let's say if dead load and live load case, if we see the bending moment diagram, then it will be similar with modifier and without modifier. Okay. Now, similarly, for the beams, if we have to apply this stiffness modifier, then it will be 0.35, 0.35 in both the direction. And again, it will be for the earthquake load case. So similarly, we discussed like for the columns, we are applying this factor for the earthquake load case. Okay, so this is the way we can apply the stiffness modifier as per IS 1893 2016 in the staad. Now let's come to Etabs. So when again, let's initially let us start with the earthquake load case, which is, let's say, for the columns, the factor is zero point 0.7 and zero point 0.7. So we have to get into this frame assignment property modifier step, and then this factor we have to make 0 0.7, 0 0.7 for moment of inertia allow about major axis and minor axis. Okay, so that it becomes 0 0.7. Now, the most important part, which I have highlighted, or which I have gathered based on the models, that stiffness modifiers are actually affecting moment of inertia for all load cases. So, unlike staad, instead, if we are applying the stiffness modifier, it is affecting only results of seismic load case, wherein if we apply this stiffness modifier in Etabs, then it is getting applied to the dead load live load case. So there was one of the query in the registration form, like how to segregate, if you do not want to consider the effect of stiffness modifier, let's say in the dead load live load case, and if you want to apply this stiffness modifier only in the seismic load case, then in that case the analysis has to be performed in stages. So in Etabs, first of all we will run all serviceability load cases, let's say dead load, live load, and wind load, for example. And after running our model, then we will apply this stiffness modifier, and then we will run the seismic load case. Okay, so accordingly, these stiffness modifier effect will be considered only in the seismic load case. So this is what I have defined, like in first stage analysis of gravity and other serviceability loads without stiffness modifiers, or let's say appropriate values of the stiffness modifiers, because it is different, as per 16700 in for the serviceability case. And for the second stage analysis of earthquake loads with the stiffness modifiers. Now, similarly, if we talk about beams, again for the ultimate load case, then this value is 0.35. So again, if you're applying it in the ETABs, it will be applied to all load cases. And let me tell you, if we're applying 0.35 and 0.7 to all the load cases, which is let's say dead load, live load case, then in fact our span moment is erring on the unconservative side, in my opinion. So that's why the stiffness modifiers which are suggested for the uh, ultimate load case shall not be used for the serviceability load cases. And again, this analysis has to be performed in stages, right? The first stage, as we discussed in the previous slide, that is analysis of gravity and other serviceability loads without stiffness modifiers, and in the second stage analysis of the earthquake loads with stiffness modifiers. Now this is very important, shear wall in ETAPS. Now, how to apply the stiffness modifier for the shear wall in the ETABS? We received few queries into the registration form, and I think it is interesting. Now here I have taken these extract from the CSI knowledge base. And if we want to apply the stiffness modifier for the shear wall, then we need to apply F11 and F22. Now here I have mentioned 0.9 and 0.7. So 0.9 is for the serviceability condition and 0.7 is for the ultimate case. Okay. So the only factors which we have to modify is this F11 and F22. Right. Now, what is F11 and F22 in ETABS? So, see, we will be modeling the shear wall as a plate element, as a surface, right? So, F11 and F22 are nothing but those are axial stresses. So, it's a kind of a stresses which will generate in a shell element because of the pull and push effect while application of the lateral load. And these M1, M11, M22, M12 are actually bending the entire plane. So these M11, M22, M12 will not be applicable in the case of shear wall. We only need to apply this F11, F22 as is zero point 0.9 and 0.7. And let's read out the interesting note which is mentioned here, that walls are generally not designed for out of plane bending, right? We are only designing the shear wall only for the in plane loading to avoid excessive longitudinal reinforcement. In this case, use a small modifier, say 0.1 for M11, M22, and M12. So numerical instabilities could be avoided. So what it is said that generally we are not designing the shear wall for the out of plane bending, and we also don't intend that the shear wall take part in the seismic load event in its out of plane bending. So that's why, see, first is f11 and f22 parameter which we have to define, and all these other parameter m11, m22 and m12 will be point 0.1. And now point 0.1 of value is suggested in this CSI knowledge base just to avoid the numerical instabilities, right? And if we have the slab in Etabs, so as per 16700, the value is 0.35 and 0.25. Now, there are two cases. We are either modeling slab as a membrane. So my preference is to go ahead with the membrane. And let's say we have gone ahead with the shell element. So these are the two different cases highlighted here. So in case of membrane, the modifiers will be F11, F22, F12 equal to 0.35, 0.25. So why only F11, F22, F12 for the membrane? Because membrane is not going to have any rigidity, any flexural rigidity. So the only modification which we need to apply is for F11, F22, F12. This M11, M22, M12 are already zero whenever it is a membrane element in ETAPS. Now, if we have modeled it as a shell, then F11, F22, F12, and along with M11, M22, and M12 will be equal to 0.35, as well as let's say 0.25. So 0.35 for the serviceability load case and 0.25 for the ultimate load case. And for both these cases, like this F11 and F22 is not important if rigid diaphragm is assigned. Okay. Okay, so this was a quick uh, presentation from my side based on the whatever queries we have received so far. Okay, so now I'm opening the discussion, and you can now put up your discussion point, your queries, your doubts, and we will start picking up, sequentially each of them. Okay, so there are many comments I could see here. Okay, in thin shell, modifiers are applying, but in membrane, we are not using modifiers. Kindly tell what is the difference. I think, Ravichandra, I have already answered your point. So if we have the membrane element, then we have to apply F11, F22, F12 as the stiffness modifiers, because the membrane elements do not have any flexural rigidity. Okay. Okay, basically membrane definition was transfer entire slab forces to beam, whereas thin shell it doesn't transfer complete load. To justify this definition, many one using modifiers on thin shell, but if we don't use modifiers as per thin shell, is that definition does not justify. So I have already answered this point. Okay. Okay, Harsh Kumar is telling that is a stiffness modifiers required for low rise or mid rise buildings performing only gravity analysis? Yes, it will be required for the low rise as well as for the mid rise building also. Right now there is no cap given in the code, but let's say if our building is less than 50 meter, then IS 1893 part 1 2016 will be applicable, wherein stiffness modifiers are defined only for the earthquake load case, which we need to consider in our analysis. And if our building height is greater than 50 meter, then it will fall into the category of 16700, and then accordingly we have to consider the stiffness modifiers which are defined in 16700. Okay. Okay, Dwarika Shrestha is telling the proposed modification for IS 1893 Part 1 2016 prepared by IIT GN, IIT Gandhinagar, has suggested stiffness modifier for slabs as well as for the structural walls, which were missing in IS 1893 Part 1 2016. Yeah, this is absolutely right. See, we need to have the stiffness modifiers for the slabs as well as for the shear wall also. So let's say if you're designing your structure as per IS 1893 Part 1 2016, then always you can take the modifiers as per 16700. But I think in the next revision, probably this would be included for the slab and shear wall for the buildings having height less than 50 meter also. Shall we need to apply stiffness modifiers while analysis? See, we need to apply stiffness modifiers for the analysis only. So, what will happen when we will introduce the stiffness modifier in our structure? In fact, the stiffness of different element will be different in the, or what I would say, the relative stiffness of the element will be different, and because of that there will be a redistribution of the forces because of the application of the stiffness modifiers. And then whatever results we get from the analysis, then we have to use the conventional process of IS 456 based on the limit state design method for the design of different elements. So we have to consider all stiffness modifiers for the analysis. Okay, Dwarika Shrestha is telling that, but BIS has not included them even in second amendment of IS 1893 Part 1 2016. Yeah, it is not included. You're right. But if you want to include, these stiffness modifiers in your analysis, then I think, or say, in my opinion, you can take the modifier values from 16700 also, which are defined for the slabs and shear wall, which which we just discussed before a few minutes. How we do exact crack analysis? Now, see, it's very difficult to perform the crack analysis and then to identify the unique value for one structure, and as well as putting the unique value for all different kind of structures. Right now, 0.35 and 0.7, whatever values are suggested, those are applicable for all different kind of structures. See, there are no cap or no parameters are given from where we have to choose it. So it's a very complex calculations, and that's why the unique values are suggested, so that at least we get little bit closer to the realistic analysis, as compared to considering 100% gross moment of inertia for the members, as we were doing conventionally. Okay, Samir Bendre is telling that, is the carbonation, chloride penetration, corrosion propagation considered in these modifiers? Excellent question. I'm not sure whether these are being considered in this modifiers, in my opinion. But this is very good question, because of this say carbonation attack, or let's say the chloride penetration attack, the extent of cracking would be substantially higher than in the normal concrete. So in my opinion, these modifiers are only for the normal concrete, but we need to study further on that. Yeah. Okay, yeah, thank you, Islauddin. We are glad that you like the content. Yes, pursuing structures from Indore. Good. Okay, Dr. Raksha from Indore. She is working as an associate professor. Yeah, welcome to this discussion. Okay, Bhushan is telling the actual load levels in columns and shear walls are different, but the modifiers of both are same. What is the reason for both having same values? Just need to justify it words. Yeah, this is an excellent question for the shear wall. See, now for the shear wall, there are two conditions. One is the cracked condition, or let me put it in the other words. Whenever we talk about the wall, there are two conditions. One is the uncracked wall, and another is the cracked wall. So let me put up the presentation once again to clarify the concept. Just give me 1 minute. Just let me share the screen again. Okay. So just let me remove this comment for a moment. Okay, so here this is an interesting table, which we just we were looking to this in the beginning. This is from IS 15988 2013. Now let's look at to the wall. Now, wall is having two categories: walls uncracked and walls cracked. So right now, when I'm looking to the 16700 stiffness modifier values, I could see that these values are closer to these walls uncracked, right? And if our walls are cracked, then this value is higher. So I also think that more clarification is required whenever we talk about the stiffness modifiers for the shear walls. Okay, so thanks for bringing this important point. Okay, just let me close it. Yes, a very long comment from Mahfouz. There is a different approach one adopt to design beams by having a different out of plane slab shell elements modifiers. Some use a negligible value in slabs and make them behave like a membrane, and some uses 0.25. I understand that we do not have any modifier for the gravity load, but also we cannot have 3-4 models to design elements. So my question is, what should be the modifiers in the slab while designing beams in combination with lateral and gravity loads? Okay, see, these modifiers are defined in 16700, and I just presented that the modifier values whenever you are considering the membrane, or whenever you are considering your element as a thin shell element. So those values I have suggested. So I will request you that you can test in your few structures, and then you come back with the results, or contact me personally, and then we will discuss it further. Okay, yes. So we are glad that you're liking the content. Most welcome. Okay. Ahmad is telling that, does applying modifiers affect the design, or does it affect deflection or drift only? Yeah, very good question. See, whenever we are applying the stiffness modifiers, what happens exactly that we are applying the reduction into the stiffness, right? Or say reduction into the moment of inertia. So we are actually reducing the overall stiffness of the structure. So let's say if I have a two model, in one model, let's say if I have applied the stiffness modifiers, and if I have the other model, which is let's say which we were doing conventionally, in which no stiffness modifiers are applied. So whenever we apply the stiffness modifier, definitely there will be impact on our structure with respect to deflection, because our structure is more flexible. So deflection or drift will increase after application of the stiffness modifiers. Okay, yes, most welcome, Rahman. Prashant is telling that, I have found that even if stiffness modifiers are assigned only for bending as required by codes, okay, the axial stiffness is also affected. The axial stiffness is also affected. If you can share a couple of snaps with me, maybe after this session we will investigate it further. Okay, Dwarika is telling that the proposed modification on IS 1893 Part 1 2016 has included 1.5 dead load plus live load in the commentary. Yeah, it might have been included, but still it is not has become part of this original code. So whatever modifiers which are suggested right now, those modifiers are applicable only for the seismic load case, in my opinion. And if we start using the same modifier for the dead load and live load cases also, then the our span moment of the beam is actually erring on the unconservative side, in my opinion. That's why we must have a separate stiffness modifiers for the serviceability condition and the ultimate condition. It is nowhere mentioned in IS 1893 Part 1 that these stiffness modifiers are not for this 1.5 dead load plus live load combination. How can we infer that modifiers are not for 1.5 dead load plus live load? Yeah, very good question. So this is my interpretation, and if you compare 16700, the factor 0.35 and 0.7 are defined only for the ultimate load case, for the seismic load case, right? And for the serviceability load case, which is dead load plus live load case, these factors are different. So this is one of the way by which we can infer that these modifiers are only for the extreme load case, or let's say for the earthquake load case. Are modifiers in steel to be used only in steel columns? Yeah, very good question. See, whenever we talk about steel structure, there is not going to be any cracking in the steel member, in steel columns and beams, and that's why we can always use 100% gross moment of inertia in the steel structures, and there is no requirement of any stiffness modifier for the steel columns and beams. Okay. Yeah, just 1 minute. Okay, welcome Subhas bhai. Okay, Dwarika is telling that clause number 7.11 of IS 1893 Part 1 clearly tells us to use the same stiffness modifiers even for displacement calculation. That's for serviceability check as well. Yeah, so that displacement calculation we have to do, and always whenever we are checking the displacement, then it will be checked for the unfactored loads only. Okay. But the introduction of stiffness modifiers in the code, one of the reason is that if we see the code, there are a number of restrictions being put with respect to the drift control. So slowly and gradually we are going towards displacement control rather than the force controlled approach, in my opinion. And that's where the stiffness modifiers would play a very critical role, because our structure will become more flexible, and that's why the controlling of drift would be more challenging. Why would we change modifiers for slabs? It would mean reducing the diaphragm action. Okay. See, reduction in the diaphragm action is suggested only in the sensitivity analysis, in my opinion. But for the normal cases, the reduction in the cross sectional, or say in the plane area, is not required. What's the difference between semi-rigid and rigid diaphragm? Okay, so this question is often coming whenever we are talking about rigid about diaphragms. So the rigid diaphragm, see, the code is defining two kind of diaphragms. One is the rigid diaphragm and another is the flexible diaphragm. So the rigid diaphragm is whenever first of all, the definition is given that whenever the extent of cutout is not greater than 50 percentage of area, right? Likewise, those kind of definitions are given in the code, and also there is a deflection pattern of the slab is also given. So from there we can infer what is whether it's a rigid diaphragm or it's a flexible diaphragm, and we can discuss and debate on this issue separately, in a separate session itself. I did not get the significance of modifiers, and on what basis are those reduction factors calculated. Okay, so see, whenever we are talking about these stiffness modifiers, we will be having the unique value. A unique value in the sense the 0.35 and zero point 0.7. Let us say, for example, 0.35 for the beams and zero point 0.7 for the columns. So this means that we have to apply this 0.35 for the all the beams, and zero point 0.7 we have to apply to the all columns. Uh, we are not required to calculate stiffness modifier values for each element manually. These values are fixed and are given in the code. We have to simply apply that unique value to the all different elements in the structure. Okay. And the second question you are asking, that what is the significance? So significance, as we have discussed, that the we can say that the stiffness modifiers are introduced into the code so that our analysis may go towards let's say towards more and more realistic analysis. Of course these values are arbitrary, it's not perfect values in my opinion, but it would be better than we are considering 100% gross moment of inertia, because whenever we are talking about the extreme seismic load case, at that time we know that the deflection or drift will be significantly higher, because we are actually reducing the earthquake forces which would likely to occur on the structure for its complete life. And that's why the displacement and drift control is important. So for controlling the drift and displacement control, the more realistic properties are to be considered, and for that purpose these stiffness modifiers are introduced. Okay, if we are performing non-linear analysis on structure, are stiffness modifiers to be used for that analysis type also? Very interesting question. Now we can discuss and debate separately on this area on non-linear analysis. Right now all Indian standard codes are talking about first order elastic analysis, so all stiffness modifiers are suggested uh, based on that only, and for non-linear analysis we can connect separately. Can we apply higher stiffness modifier to the beam, considering beam as a T or L beam to reduce higher forces in columns? In my opinion, it is not permitted. We cannot alter the values of the stiffness modifiers, because we are not performing any exact calculations for deriving this values. And that's why, in my opinion, we should not alter these values, whichever are defined in the code. Okay. Sir, I request before going into the values, kindly explain the essence of the modifiers, like how they affect design, deflections, drift. If at all, is it necessary to apply modifiers at all as per code? Yes, we need to apply modifiers for all the structures. There is no cap, there is no demarcation, and as we have discussed that the drift will definitely increase when we will apply the stiffness modifier. Now one more interesting thing will happen when we apply stiffness modifiers. The structure will become flexible, right? So because of that its time period will increase, and when time period will increase, what will happen, then my earthquake force value which I am applying on the structure will reduce. And that's where the scaling of the base shear will come into the picture. So in any case we have to apply at least minimum base shear value, which is derived from the empirical time period formula from the code. So there are two kind of control which are being exercised into the code, in my opinion. So firstly, see, the force is also getting increased because of the scaling factor, and secondly, while checking the drift our structure is more flexible, right? So this is the overall impact, in my opinion. Okay, Krishna Sahakari is telling that just a theoretical question: for multi-storied building, the stiffness modifiers would differ on ground floor column compared to the roof level columns. Yeah, it's a good question. So so that's what the exercise has been done into the while deriving these stiffness modifiers, in my opinion. uh, and you're right that actually if we going on measuring the actual values, or if we perform very detailed calculation, if we perform full scale testing by applying different forces, and then also there was a very good question related to the corrosion. So if we combine all these different factors all together, then definitely the extent of crackings will be different in a different elements. But right now, the values are defined as a single unique value for the entire columns, entire beams, irrespective of their location into the structure, irrespective of type of structure, irrespective of any height of structure, or let's say the irrespective of a kind of a irregularity the structure is having. Okay. Okay, Dwarika is telling that ACI has a different provision for the strength design and the serviceability check. It allows to increase the stiffness by 1.4 times for the serviceability check. Thus, different codes have different provisions. Yes, you're right. Let's not discuss it into much detail. If required, we will have separate sessions on this wherein we will compare modifiers with the other codes. But you're right that when we compare to the ACI, it is having different provisions for the serviceability and for the strength requirement. And that's what I am suggesting, that the stiffness modifier should have a different value for the serviceability condition as well as for the ultimate condition. Okay, if we assign slab as a thin shell, then is there any change in a conventional design and detailing? Good question. Now, I think on this shell versus membrane itself, we can have a one dedicated live discussion. So I'll also request. See, right now I have mentioned the email address on the screen. Here you can see this is the email address. So you can mention the topics, details on which this kind of a live technical discussions are required, and based on that, we are going to organize. So we have quite aggressive plan coming forward. So if you have not yet subscribed to the YouTube channel, please do it, because, so that you will receive the notification whenever we go live. So I'll try to answer this question very briefly, but we will discuss it in detail in one of the session itself. Whenever you are taking your element as a thin shell, what is happening then, it is actually transferring the loads to the columns and the beam, and that thin shell element is also becoming integral part. So there is a certain load transfer which is happening to the columns and beams, and the certain part of slab is also taking part into this. And that's where the stiffness modifiers would be required. And definitely, if you will compare, the conventional design and detailing will be different if you consider thin shell without any stiffness modifier, right? Because it is changing the entire behavior, in my opinion. Okay, Sunil is telling that in PB design, no one uses stiffness modifiers in design. Is it mandatory to design using stiffness modifiers for earthquake loads? What about AISC design? Okay, so let's say if we are talking about PB, so I believe that you're talking about the steel structures. So for steel structures, as we just discussed, that for steel columns, beams, stiffness modifiers are not required. Now, if you are going ahead with, let's say, RCC structure, or let's say for the precast structure, for the as a concept of PEB, definitely these stiffness modifiers will be applicable. Okay, Ahmad is telling that can we apply modifiers for building less than 50-meter height? Yes, we have to apply stiffness modifiers for buildings having less than 50-meter height also. So what will happen? See, if my building is less than 50 meter, then IS 1893 Part 1 2016 is applicable, and beyond 50 meter 16700 is applicable. Okay, okay. So thanks a lot, Vijay Kumar, and we are glad that you have liked the session. Okay, Ravi Teja is telling that for time history analysis, wherein acceleration time of a particular earthquake is given as an input without considering response spectrum, then such case, is it required to use a stiffness modifiers? Yeah, see, stiffness modifiers are not at all dependent on the analysis procedure. So whether it's a time history analysis, whether it's a response spectrum analysis, we will have to consider the stiffness modifiers, because it is actually a property of the concrete members. And basically, as we've discussed 2-3 times, that the we are considering stiffness modifiers to account for the probable cracks or the extent of cracks which our structure, or let's say which our RCC structures will have. So irrespective of type of analysis, we will have to consider the stiffness modifiers into consideration. As per 16700, we apply stiffness modifiers, and we have to take results with modifiers, and we design the structure. Okay, let me read out again. 16700, we apply stiffness modifiers, and then we have to take results with modifiers, and we design the structure. Yeah, that's you're right. Like, we have to apply the stiffness modifiers, and then we have to take the analysis results considering the stiffness modifiers, and then we have to perform the design of different elements. Yeah, okay, welcome, Bhushan. Okay, Prashant is telling, what about effect of creep on the modifiers along with cracking in tension, which reduces the moment of inertia. Creep would reduce the E, therefore also reducing the EI. So do you think the effect of creep is considered in the modifiers? So honestly speaking, I'm not sure like what are the exact consideration which has been taken while deriving these parameters. But this is an interesting question. Like, one question was related to the corrosion kind of a cracking. Now this is the creep. So in my opinion, the certain extent of different elements would have been considered in this value. And you're absolutely right that all these factors really affects the value of the stiffness modifiers. And that's why, just to make our life simpler as a practicing engineer, we have a defined unique value which we need to apply in our analytical model. And definitely the separate researches can be undertaken, wherein we can study the effect of on stiffness modifiers because of these several important factors. Why are the stiffness modifiers different in IS 1893 Part 1 2016 and IS 15988? What is the logic? Okay. So there is no logic, in my opinion. Uh, uh, and probably this differences may be sorted out into the upcoming version. Maybe the references which might have been referred would be different while making the codes, because 15988 is relatively earlier, we can say relatively earlier code as compared to 2016. So personally speaking, I do not see any specific logic for having different values of the stiffness modifiers in two codes. Okay, to take into account backstay effect, table 7 mentions that the lower bound and the upper bound modifiers for the retaining walls. Again, in clause H.1.3.3.1a, code mentions to design vertical LLRS as per both direct load path and the backstay path. This is confusing. Please share views on this. So certainly these are good question. Like, let's have separate discussion on the backstay effect. But for a quick reference, you can refer the document which I have presented. Okay. Checked on strap software, the model with the stiffness modifiers results almost 50 percentage to 70 percentage increase in the steel areas as compared to the model without stiffness modifiers in the RCC columns and the shear walls. Okay. Okay, so it would be great if you can share a few more details with me, and we can also cross check, in the different software, or we can check, manually also certain parameters if possible. What's the difference between shell thin structure and the membrane structure? See, shell thin structure, whenever we say the shell thin element, then this element is having a capacity of withstanding, or let's say this shell thin element will resist the force along with the axial elongation as well as along with the flexural rigidity, wherein in case of a membrane structure it is going to have only axial rigidity. There is no flexural rigidity available for the membrane elements. Okay, yeah, just 1 minute. Okay, please share any model so that results can be visualized clearly. Definitely we can do it in the next sessions. In RCC beams, there is a negligible increase in the steel. That's what he has observed. Okay. I think these modifiers are for lateral as well as earthquake load cases, since during occurrence of earthquake shaking, members will get cracked and the bending stiffness will get reduced for vertical as well as lateral loads. Yes. Okay, Akash is telling that if we reduce the stiffness, since we can't have element separation in FEM based models for realistic modeling, but what if we use applied element method based model which allow element separation? Akash, your question is not clear. If you can elaborate with more details, we'll take it up. Is creep is automatically considered if we adopt modifiers? Yeah, so personally speaking, I'm not sure about this creep consideration. In my opinion, we need to consider creep separately. But let's have a few more study on this, and then definitely we may be able to reach to certain conclusion. Why we are applying stiffness modifiers with respect to software point of view, like Etabs, staad.pro for earthquake load? What's the question? Why we are applying stiffness modifiers with respect to software point of view? No, we are not applying stiffness modifier from the software point of view. In fact, we are applying the stiffness modifiers values whichever suggested in the code. How we can apply into the current software? That's what we are looking at. I think that's what your question is. Or okay, so if you're not satisfied with the answer, please put it in the next comment box. What shall be modifiers for composite deck? Yeah, good question. In my opinion, these modifier values are not suggested yet in the code. IS 1893 code says that it is necessary to tie foundations in both direction. Please explain the concept. Let's take this topic separately. This is also a very interesting point. Is it necessary for small structure like guard houses? I believe your question is that whether we should consider the stiffness modifiers or not. So whether it's a guardhouse structure, or let's say whether it's a 30-40 meter height of structure, we need to consider the stiffness modifiers as per the IS code. Due to fatigue in a steel member, some surface crack is possible, okay, especially due to crane movements or at weld location. So is it not required to consider steel beam modifiers in that case? Yeah, there may be these are rare cases in which surface crack is possible, but it will not alter, in my opinion, the moment of inertia to the extent which it is getting modified into the RCC element. And that's why probably the code is telling very clearly that for steel structure you need not apply the stiffness modifiers. Okay, Faisal is telling what is the significance of base shear. Your question is not clear, Faisal. If can you please elaborate it with more details? Code is silent on crack parameters for braces. Your thoughts, please. I'm not getting your point. Silent on crack parameters for braces. If you can please elaborate it with more detail, we'll take it up. Is it necessary for small structures like guardhouse? Yes, it is required. If I have two same buildings and if I am getting lesser base shear in one and greater another, how can I say which one is better? Okay. Now, see, the extent of base shear depends upon a number of parameters like your extent of building, the mass of the building, then your stiffness of the building, etc. Right. So, if you have exactly similar kind of a geometry in which if you have gone ahead for a different structural configuration, and let's say in one of the building you are getting the lesser base shear. Now, what in the building wherever you or let's say in the structural system, whenever you are getting lesser base shear, that means your structure is relatively flexible. So so the drift check and other necessary check with respect to drift and deflection should be satisfied, right? Okay, Rahul is telling that figure 6 of IS 1893 shows how to identify rigid and flexible diagram. Yeah, yes, thank you for sending this message. This figure shows very clearly. Now, how to find correct moment of inertia of column? Now, it's very difficult, to find out this correct moment of inertia for application in the analytical model, because there are a number of factors, yeah, which will affect it. Yeah, and that's why code is not giving that liberty also, that you calculate the stiffness modifier value manually and then you apply into the uh, analytical model. Is stiffness modifiers need to be applied for steel filled concrete members? Yeah, good question. So right now code is silent about this parameter. But what will happen? See, if you have a steel filled concrete members, now this is a different kind of an element. Like whenever I have a steel filled concrete members, in these, my overall design philosophy is that the entire tension will be taken care by the steel element, which is in the periphery, and the concrete will be under pure compression. So it's a kind of a win-win situation for both the concrete and steel. So because of these, the extent of cracking would be very, very less into the concrete. Right. Okay. Okay. Thanks a lot, Dr. Ajesha. Okay. Okay. Thank you. Okay, Ravi Chandra is telling, I mean, let us suppose with modifiers, I got my slab deflection 20 mm. Without modifiers, I got 10 mm deflection. So I have to design my slab for 20 mm deflection as per 1893 and 16700. Yeah, you have to consider effect on deflection from the modifier also. Is it necessary to apply the stiffness modifier during ultimate limit state? This consideration in design will allow the formation of plastic hinge in suitable location of a member. Yeah, I'm not getting your exact question. Let me read out again. Is it necessary to apply the stiffness modifier during ultimate limit state? Yes, we have to apply during ultimate limit state also. And this consideration in design will allow the formation of plastic hinge in suitable location of member. This, okay, let's take it up separately, with the non-linear analysis, which is an advanced analysis. During that discussion, we will touch upon this very important aspect. Now, what is the basis, is the ratio in the inter-story drift value from Etabs. So whenever you are applying this stiffness modifier, your inter-story drift value will increase. And whenever we are talking about earthquake resistant design concept, the inter-story drift is more important, right? Are modifiers dependent on life of structure? Okay, good question. So right now there is no cap on the life of structure which is mentioned in the Indian Standard Code. So I think general life of the structure would have been considered while considering these modifiers, because your question is absolutely right. As and when the aging of the structure increases, the extent of cracking will also increase. Right? Okay, thanks a lot, Krishna Sakariji. So, how do we apply the modifiers for spandrel and piers? That's what we discussed. That for the shear wall, the parameters we should apply. The way I have made in a small presentation. So let's try in a model along with the options whichever I have mentioned in that small PPT, and then we can discuss it in more detail if there are any problems. Okay. Okay. Most welcome, Olau. I have little doubts. Can I send them on your mail ID? Yeah, please share on this email ID, which is there on the screen, which is mentioned here. As you said that after applying modifiers, structure become flexible, but as well as drift is out of control. So while designing 22-story building, yeah, that's why. See, whenever you will apply the modifiers, the flexibility of the structure will will increase, and probably the consideration of drift is going to be critical, right? And that's why where we will have to alter the stiffness. But again, while checking the drift, there is one more clause in the code that we need not scale the earthquake force while checking the drift. Now again, there is a difference of opinion which I have received from different engineers. But as of today, we can say that while checking the drift, we can use unscaled earthquake force. Okay, thanks a lot, Ganesh Kumar. Most welcome. Is there intermediate solution to above mentioned two condition? So you can contact me on that email address. We can discuss with the specific case. Okay, so how does a stiffness modifier affects serviceability check? Okay, so whenever we are applying the stiffness modifier, the deflection or the drift will increase, and and that's why it will have the impact on the serviceability check. Okay. Okay, so thank you all for raising very interesting questions, and I am sure that you some of them I have been able to answer. Okay, sir, should we apply modifier to the members, then design it, or we can design the structure without applying stiffness modifier? Please elaborate on this. Okay, see, whenever we are talking about the stiffness modifiers, firstly we have to apply the stiffness modifiers in the analysis. And then whatever results we get from the analysis, those results should be used for the design of the structure or design of different elements. Okay. Is this stiffness modifier is for rectangular beam or T beam? It's so important to consider T beam during seismic case. If not considered, then strong beam weak column may come in action. See, right now there is no demarcation whether it's a T beam or whether it is a rectangular beam. I think the only pure logic is that the beam is going to have a pure flexural kind of action, and because of that, the extent of cracking would be higher in the beam in relation to the column. And based on the certain experiments and literatures, probably this unique value is defined. Okay. Okay, so thank you all for raising very interesting questions related to stiffness modifiers, and I'm sure that still you would be having certain more doubts. So you're free to share any further doubts whenever these video will be published on a YouTube. Okay. Let's take a couple of questions and then we will close today's session. Is applying stiffness modifiers is to increase ductility property of members? No, see, we are applying stiffness modifiers to have, let's say, our analysis more closer to the more, let's say, the realistic analysis. Earlier, we were considering 100% of gross moment of inertia for the members, right, before introduction of stiffness modifiers. So these modifiers are introduced only to have a kind of a analysis which is more near to the realistic analysis. Again, after applying modifier, we cannot say that it is 100% realistic analysis, because the modifier value will vary from member to member depending upon the location of the member, type of the structure. But just to make it more practical, the unique values are identified. Okay. Okay, most welcome. Okay. Okay, most welcome. Okay, so that's all from our side today. Okay, so we are closing this session. And please keep on posting your topic at the email address which is mentioned on the screen, right? And also please suggest future topics on which we can have this kind of a discussion. Okay. Okay. Okay, inclusion of stiffness modifier is making this design realistic, and slowly IS code is also moving towards the displacement based design. Absolutely right. Okay, most welcome, Krishna Sarkari. Yeah. Okay, so looking forward to more interesting this kind of a conversation. So please feel free to share details at the email address which is mentioned on the screen. You can also suggest the topics, details, etc. And in the next week, we will be coming up with the online course related to steel structure design, which is Steel STR 001. And in that, again, we are going to decode IS 800 2007 along with the current software, which is Etabs and staad.pro. Right. So if you are interested, still registration is open. You can register. The course will start from 28th September, which is Monday. Sorry, Tuesday. Okay. So already future topics have started coming, like pipe rack structures. Great. Okay, so thank you all, and now we are closing this session, and the next live discussion we will have on the next Friday around 7 p.m., in which we'll be talking about concrete mix design. So we had part one of the concrete mix design, and then we will be having part two of the concrete mix design on 1st October around 7 p.m. Okay, so just keep following us. We are coming up with many interesting online discussions in the coming time. Okay, so for bye from our side, and we are closing this session now. Okay, bye bye.